In this screencast, we'll continue the program design that we started in the previous two screencasts. If I look at the recipe, the last thing I have to do is design functions that will analyze the data. If I go back to our program, we can see that our main function is still commented out. I'll work on this function. Following our How to Design Functions recipe, first I need to do the signature, and I need to remind myself what this could return. There's a couple of places I could look for this, and they'll be in the planning phases, because that's where we decided what our function was going to do. I could look at the example in step 1c, or I could look at the question that we're going to answer. I remember that I want this function to return an int, an integer for the year. Now I'll write the purpose. Reads the file from the given file name, and returns the year with the largest population growth as a percentage. Now that we've updated the signature and purpose for main, it's time to start writing the examples. As we saw when we worked on step 1c, writing the example for the program, if we wanted to use our main information file for the example, we'd have to go through the whole information file and determine the right answer. But that's the whole reason we're writing this program. So instead of doing that, when I'm writing my examples for main, I'll use my two test files. They are much smaller, and I can go look at them and determine which answer I actually expect. In this case, I know that the year with the largest population change as a percentage for my first test file was 1975, and for the second, it was 2010. Let's finish the implementation for main. I can see that main is based on a function composition, and the template comes from the How to Design Analysis Programs template. The first thing that this function will call is read, and read will return a list of population change data. Then we need to pass that to a function to do analysis. If I tried to run this code right now, it would not run because analyze is not defined. That's our next step. The last step in this recipe is designing the functions that will do the analysis. I want to give this function a more meaningful name. The name analyze comes from the template, and we have to use a generic name there because we don't know what problem the programmer will be trying to solve. But now that we're working on a particular program, we can give this function a better name. I'll call it highest population growth. I know if I ran my code now, it still wouldn't run because highest population growth is not defined. I need to design that function. Highest population growth will take a list of population change and return the year with the largest population growth as a percentage. We already know how to design this function, so I will copy and paste in a fully designed function rather than designing it as part of this screencast. I've pasted in that function design, and as always, that includes the appropriate tests. As I was designing this function, I realized I needed a helper function to take two population changes and determine which one had the greatest population increase by percentage. I've also designed a helper, larger population increase, so we can see that and of course its associated tests. When I run this program, I see all of my tests pass, so we've completed our analysis program. We can now use our program to see what year had the greatest population growth as a percentage between 1975 and 2012. If I call main and give it our main information file, it tells me that the year with the greatest population growth as a percentage was 1980. We've completed our program and it's able to answer the question that we wanted it to answer. One last comment. If I look at this design for larger population increase, I can see that it takes two population changes as input, and therefore its template has access to all the selectors or all the fields from each input. So this function design is an appropriate function design that following our recipes and our helper rules would get us to. But if I look at it more closely, it might be accomplishing two tasks. It's figuring out which population increase was higher, but also figuring out what the population increase was for each year. We could choose to design a helper function to figure out the population change as a percentage for a given population change year. I won't make that change here, but that's something that you could choose to do if you were designing this program yourself.